Alright, this video is mostly about saving a circuit in Falstad, but there is something I want to cover really quick. If you look at this waveform here, this is the current. Well, this current actually should be balanced just like this voltage waveform. Um, and, this waveform is measured, those two waveforms, are measuring the current and voltage, through this wire segment right here. But you'll notice that the yellow waveform is our current, right? But it should be balanced just like the voltage waveform is. In other words, you can see it's like offset to the top. And the reason is, and I've run into this with capacitor circuits before and everything, and usually on professional simulators don't get that because they usually run a transient analysis before they actually start showing you, live data or whatever, they get it to steady state before they start showing you. Well, they don't do that on Falstad. So as a result, if you get a waveform that you're like, why the hell is this out of balance? Because this should be, you know, have an equal current on top and equal peak current on top and bottom. Well, the reason is because, it's too early in the simulation, so you got to run it like at high speed, until that thing starts to balance. And, if you observe it long enough, and it can take an excruciating amount of time to do that, but, you'll slowly see that yellow waveform there starts going further and further down and starts becoming more and more centered, like you would expect, because it should look like this waveform here, which is nice and centered sine wave, about the the zero line. And you can see already, it's gone down quite a damn bit, from what it was when I first started showing you. See, it's a lot more balanced now. Hey, you might have to run this thing for several minutes to get it up to, to get that waveform balanced, because it's having to charge the field of the inductor. And they're really just duplicating what would actually happen in real life. Too. So anytime you're dealing with large inductances or capacitance, it can take a while for it to stabilize, to its normal operating level. So, which we're about there right now. So, you can see what the time is. It's like at 4 seconds in. So, in the real world, it could take several seconds for a rather large inductor to stabilize in a situation like this, or if it's some kind of an output capacitor, like a coupling capacitor, between amplifier stages or whatever. If it's large enough, that could take that a while to stabilize too. And, it can really confuse you if you don't know what's going on, because you just don't normally see that in simulators. So, but see, it's about balanced right now. So, as I got it so that it adjusts itself or whatever to the peak readings. So that's why this thing shifts its scale, because this is how I set this thing up right here. I got it auto max on the horizontal. I'm showing voltage and current depending on the plot. Because I actually got several waveforms on here, as you can see. I not only got this wire on here, but these two meters as well. That meter. That makes me kind of wonder. Just to finish my point, I went ahead and added this meter to it too, so you can see it's like out of phase from this meter, by 180 degrees. This other trace, the brown one, is actually the voltage drop, I think, across this transistor. So, it's going to be the same shape. It's a negative voltage drop, so that's how it's showing up. But at any rate, the point is that it takes these waveforms sometimes, with reactive elements, in particular to stabilize. So, something to be aware of in Falstad. But if you want to actually save a circuit, you can certainly go save as and save it to your computer, and but that's one way to do it. You can save it, as a file on your computer. It's really just a big text file, though, so you got to go into that text file, grab the text, and take it and stick it in a Falstad system. And I don't know if you know this or not, but they actually make a standalone non-internet based Falstad. It's on their same website. Um, a lot of people don't realize there's a lot of shit on Falstad. I mean, not just this thing. Um, but they actually do have a standalone version of it. Let's see. It's not really that easy to get to. Yeah, I mean, this text string is so friggin' long. So if you go to falstat.com, they really have a lot of little applets, but the circuit simulator, they actually do have a version of this you can download to your computer, so you could run it offline if you wanted to. But you'd have to dig for it out there. I'm not really sure where it is, but they also have a lot of other little simulator things on here for all kinds of different things. So it's just, it's kind of an interesting site. If you've got some time to check it out. But at any rate, going back to my circuit here, yeah, you can save it to your computer, but it's just as a text file, so that's actually kind of a pain in the ass. You can export it directly as text, but it's basically doing the same thing here, I believe. That's, I guess, taking a screenshot of it, probably. Although there's other ways of doing that on a computer, but I guess you can export it as an SVG file, whatever that is. Yeah, you can copy the image to the clipboard, but what I usually use is I export it as link. Now, right here, here's the link, right? And you can create a short URL if you want, and hit copy to clipboard, or you can just, damn it. It's easier to hit copy to clipboard, but, you can certainly copy it like that, right? And just hit OK once you do that. Okay, then you go over here, okay, and then Control V it, paste it, but you'll see that it expands that tiny URL into a big, huge, long string there, but that's actually describing your circuit. So that's basically, that's basically how it works. And you can see that, my waveform, yellow current waveform, is not centered again. So, you got to run it for a while. But, the point is that once you do that, okay, I've got it pasted up here now as a current URL. So I can just save it as a bookmark, right? So, let's see. Oh, it's in theory, yeah. But anyway, I can just save it as a bookmark, and then I can bring it up, at will, just by going to my bookmark section and, pulling it up. So that's basically how you do it. But like I said, you can also generate that tiny URL, and this is what I'm going to do in a YouTube video, or at least try it. You can create that URL, copy it, and then go paste that in your YouTube video in theory. So, not tried that yet, but I'm about to. So anyway, cheers.